Okay, so the first part of this class is all about handling data in a very broad sense, not necessarily running statistics on it, but just getting the data into your system, making some charts and graphs. And now we're going to talk about processing and preparing data for analysis. Now, I'm going to use some of the slides that Dr. Thatcher made because, of course, he is awesome at slides. And so here, let me just share my screen. There we go. And so we're going to be using the package dplyr. It's part of the tidyverse package. And so if you haven't done it yet, go ahead and open up RStudio. I did mine inside of that VM virtual machine. And open up your package, not your package, your project, so that you're ready to go. Now for this first part of dplyr, I'm just going to make a new script window. So you go over here to the plus window, I'm going to make an R script. Not R markdown for this one, just an R script, because we're going to be doing some simple things here. And so first thing I'm going to do is I'm going to load the tidyverse package. And if you have it already loaded up here, you just go ahead and do that, hit Control Enter, and it'll get loaded. And I'm going to load in the car package. You remember the car package had several data sets that we like to use. And one of those data sets is just called Titanic Survival. And there you go. And notice that I used the tab to autocomplete it because typing out things is a pain. It shows what it has. And so for each of the passengers, it gives you their name, whether or not they survived, yes or no. Well, none of them have survived now. Sex, male or female, age, and their passenger class. And so that's a very good data set. And I want to get it loaded in here to our script window. So I'm going to actually just make a new command. I'm going to call it Titan, just so it's one less thing to type. And Titanic survival. And when I hit Control Enter, you can see that Titan was put over here. There are 1,309 people in it with 4 variables. And so here you can see how it's all recorded. Notice that the name is actually put in as a data label rather than as a variable, and that can sometimes be cool and sometimes be a pain. I've never taken the time to do that, but the data sets you download from within R, I've often done that to you. So there we go. So again, you can push this little play button here and it'll show you the variables. And that's kind of a nice little thing to do when you don't want to do one of the more formal things. But of course you could do summary Titan. And that gives you a summary of the variables. Notice that it counts the factor variables and it gives you numerical data, that 6-number summary of the age variable. It also has NA for the 263 people that we don't know their age. One thing that's sort of interesting, and you can see it whether you see it there or if we go to view, remember view is the way that we can look at the data set up here. But anyway, one of the things you can see here is that Master Hudson Trevor Allison survived, was a male, and was 0.9167 years old. And that's sort of weird. I don't think you go up to a mom and say, how old's your baby? And the mom says, oh, he's 0.9167 years old. And so it turns out that that's really 11/12. So you can't imagine a mom saying that your child is 11 months old. And this data set already converted all of that into years. The rest of them have whole numbers for people. And you can even see down here, there's one that is 0.1667 years old. So that's a 2-month-old. All right, so now that we've checked out that, and again, you can think of which is your favorite way to look at variables using the summary command, the view command. We used the head command before. And remember, that gives you the first few rows. In a script window, when we're just playing, I actually think view is probably the nicest. But if we're going to do a knit R markdown, then one of these other ones works better because view just makes a pop-up window, which doesn't do it. And again, this isn't for reporting. This is for you figuring out what's going on in your data set. So I'm going to keep going in this window. What you might want to do is use the hashtag. Remember, hashtag makes things comment. So if you want to take some notes, you can put comments and notes right into your script window. Then you might want to save it. So if we hit save, it'll ask us how to do that. And since we have the project open, it'll put it right in that right folder. We might call this the dplyr intro. So you can write that we're going to use the Titanic data set for that. And you can put the .r. If you're on your own computer, it'll actually default to that, but on the virtual machine, it doesn't necessarily. So we go ahead and save that, and now we can keep putting more things into there. All right, so when you do save those, you do want to give those a descriptive name. Don't just call it like week 2B or something like that, but do something so that when you're looking in your folder later, or you're like, how can I remember those commands for dplyr? It'll help you figure that out. So the reason we're going to talk about this as such an important topic has to do with the idea of reproducibility. If you haven't watched the big idea video about reproducibility, you probably want to watch that now. Go ahead and pause or quit this one. I'll wait. Have you watched it? Great. So one of the pieces of reproducibility is the idea of how we think about data. So if we go back to Dr. Thatcher's slides, this idea that reproducible analysis allows you to go all the way from start to finish in a really nice format. So we've already done data visualization, which is one of the parts of this model. So we get our data, we make it tidy. We'll talk about that in a couple videos here in the future. Then we transform it into something useful. We make visualizations to understand what's going on. We make models that try to predict what's going to happen in the future. Sometimes we do this a couple times around, that after we make the model, we think of different ways to transform it or different ways to visualize it. Once we have a good sense as a data scientist or a statistician or a data manager of what's happening, then we figure out how we're going to communicate the results so that people can make the best decisions they can. And of course, sometimes we're the people making our own decisions, but we want to figure out how to do that. Now, it is the case that certainly as statisticians, we love to plan how to make data in the first place so that it's already tidy, so that it's already in the format we need. And if you get a chance to do that, that's great. In fact, in stats, we teach a class, Stat 210, which is all about data collection and field methods. So it gives us ideas for how to think about data on the front end so that it's easier to work with on the back end. And so that's a win situation if you get that. But in a lot of cases, the data is what it is, and we've already gotten it how it is. So in a really simple way, you could imagine that I have a column of dates, and some people recorded their dates as January 15th, 2011. Others wrote 1/15/11. Others wrote 1/15/2011. Some might have written 1-15-11. Someone else may have put January 15th and assumed you could figure out what year it is, and maybe you can from other information that you have. Some European people would write 15/1. Now, while we can argue about which one is better, and in fact, there are lots of data people who really think about that a lot, we do have the LubriDate package, which is a system totally set up to make dates more equivalent. Today, though, we don't care. We just want all our dates in the format so that we can analyze it. I want to make a chart, I want to predict it, and I want all the Januaries to go into the same bar chart. And so we need to transform it into a way that we can use it. You can imagine that you have several stores, and every day at the end of the day, each computer sends the sales data from that store to your central server so that you can process it. Maybe one store has an older computer and the data is kept in a little bit different way. Now, you know, they're going to upgrade that computer next year, or they're going to close the store. Maybe they don't know they're going to close the store. But for now, you're going to have to just live with it. And even though you're the data guy, you don't actually get to make decisions about how they collect data. So we got to figure out how to get the data into the right column heading so that we can do stuff with it. We'll talk about how to make data more tidy in a little bit, but we tend to think of data as a data frame. In tidyverse, sometimes they call it a tibble, which is a specialized one that tidyverse has. And a data frame typically represents data in a tidy way. And a tidy way means that each column is a variable, each thing we're measuring, and each row is an individual. I had a grad school professor who said each row is a dude in a not very gender neutral kind of way. So we have these tan columns and we have these purple rows. So a variable is a column, an individual is a row. If your data looks like something else, we want to make our data look like that so that we can do things with it. A data frame is just the interaction of that, and a data point is where the columns and the rows intersect. So observations, characteristics, data points. Like that. Okay, so dplyr has 5 commands that we're going to use to move things around in order to make things cleaner and easier to use. So that the videos don't get too long, I broke them up into multiple shorter videos. The next video, the second one, will be filter, select, and arrange. The third one will cover mutate, the important idea of a pipe chain, which is how we put them all together. And then the last of the commands, summarize and its friend group by, will be covered in the one after that. So I'll be right back here to do the next one, which talks about filter, select, and arrange.